This is the homework helper for Chapter 5, Section 6 in the 8th grade textbook entitled Dilations. So what we're supposed to do here in the first two questions, same directions, we're supposed to tell whether each transformation is a dilation. Remember, a dilation will indicate that when we're going from the pre-image to the image, that the scale factor used to multiply the sides, whether that's a whole number or a fraction, is the same. So if we look at this one here, these two trapezoids, if I start with this guy on the top, he's 1, 2, 3, 4, 5, 6 across. And when I come down here to this one here, it's 1, 2, 3, 4, 5, 6 across. So there, to go from 6 to 6, the scale factor is 1. So I'm looking to see that that same scale factor applies all the way around the shapes now. So if we go from the bottoms here, we've got 1, 2, 3, 4 across, and on the bottom here, 1, 2, 3, 4 across. So 4 to 4 has a scale factor of 1. So that's good. If we would have gotten a different scale factor there, my answer would now be no. Now when we're looking at these heights, we see that these heights here, or rather these, the non-parallel sides of the trapezoid, I guess I should say, cover from 4 to 1 here, for instance, and 4 to 1 here. It would match up with a height of 3 here. Realize it's not exactly 3 because it's going diagonally across the box. But notice that these ones do the exact same thing. They would correspond to a height of 3. So those are also a times 1 scale factor there because they are the same. So my answer here is going to be yes. These are dilations. They're actually identical, exactly the same. But because the same scale factor is used all the way around, that's going to work. If you would have gotten a different scale factor at any one point, then the answer would be no. So if we look at this one here, these kind of squarish looking shapes, we see that the height is 3 here, and when I come over here, the height is 3, 4, 5, 6. So we're going from a height of 3 to a height of 6. And when we're looking at the widths, we've got a width of 3, and that confirms this is a square because we have right angles. When we come over here, it's 1, 2, 3, 4, 5, 6. So to go from the heights 3 to 6 means I'm multiplying by 2. And these widths 3 to 6 means I'm also multiplying by 2. Since the same scale factor works all the way around, this one is another yes. Remember, the other thing you need to check when you're looking at your dilations is the angles. Whether or not I make the sides bigger or smaller doesn't matter. The angle should still be the same. So if like a right angle changes into 87 degrees, instantly we can answer no because the angle should still be the same. The only thing that's going to change is the length of the sides. All right, let's go ahead and take a look at number 3 there. Number 3 says to dilate each figure by the given scale factor with the origin as the center of dilation. What are the vertices of the image? So, the first one there is the trapezoid, and the trapezoid is, we're told to multiply it by a scale factor of 2. So remember, as we saw in the notes today here, what we want to do here is list the coordinates. So point A is at negative 2, 2. Point B is at 3, 2. Point C is at 2, negative 1. And point D is at negative 1, negative 1. What we did then, as we saw in the notes, is we multiplied by the scale factor. So whatever the number is they tell you to multiply by, you multiply the whole thing by. So since it says a scale factor of 2, I'm going to multiply each one of these by 2 to come up with the coordinates of the image, the after. So when I do negative 2 times 2, negative 2 times 2 is negative 4, and 2 times 2 is 4. 3 times 2 is 6, and 2 times 2 is 4. 2 times 2 is 4, and negative 1 times 2 is negative 2. Negative 1 times 2 is negative 2. Again, the same there. So those are my new coordinates. Now I'm going to label those coordinates on the graph. We've got negative 4, 4. That's my new A.
6 comma 4 is my new b.